Hi geometry peeps, welcome to Unit 11 Day 2, and we are going into Similarity of Triangles. And what we're doing is determining whether or not triangles are similar based on different similarity schemes, just like we did when we were doing congruent. Now if you remember back in the dark ages when we did congruent triangles, we had a couple different ways we could prove triangles congruent. We could prove them using side, angle, side. We could prove them using side, side, side. We could prove it using angle, side, angle. We could prove it doing hypotenuse, leg. And we could prove it doing, I've forgotten the last one. Side, angle, side, angle, side, angle, hypotenuse, leg. Angle, angle, side. Okay, and the ones we couldn't do were angle, angle, angle. Those were not allowed. And we couldn't do side, side, angle. We couldn't do those ones. And those were how we proved congruent. Well, when we're proving similarity, again, we have a couple setups where if you have sides and angles together in certain combinations, then you can say definitively that the triangles are similar. And so to start off with, our first one is angle-angle similarity. And so if you have two triangles with two angles that are corresponding, that are congruent. Okay? So if you have two sets of angles corresponding that are congruent, then, well, if you recall, since triangles have to add up to 180, those third angles are automatically going to match up. And the way we write this is to put AA and then the similar sign. And so if you have an angle that's congruent and another corresponding angle that's congruent, then you have enough to prove the triangle similar. Okay? And so let's look at some examples to see if we can prove it. So let's determine if we have some triangles similar. In this first one, notice that I am given that these two segments are parallel. I know that because they have these arrows, and those are our symbols for lines being parallel. Because they are parallel, being cut by this transversal, I know that alternate interior angles here are congruent. And then also, I know that these angles here in the middle are congruent because they're vertical angles. So now I have two different sets of angles being congruent. And so then, yes, the triangles are similar. Now that I know they're similar, I need to write my similarity statement. And so I'm going to start off with this triangle on the left, and I think I'll name it triangle DCE. And I'm going to say that it is similar to this other triangle. Now, when I do that, I need to make sure to name the angles corresponding. So if I started with angle D here, the congruent angle to it is F. So I need to start with F over here. Then on my left-hand triangle, I went to angle C. It's not marked. My unmarked angle in this triangle is G. So since C was second here, G will be second here. And then my last angle that I named in this triangle is E. And the one that's congruent to it is also angle E, and so I will put E on the end here. So triangle DCE is similar to triangle FGE. Now that they're similar, then I know that all the properties of similarity are going to fall here. So not only are all the angles going to be congruent now, but now I know that these sides are going to be proportional to each other. I'm not doing anything with that right now, but knowing that about similar triangles is going to let us continue with that later on. Looking now at problem number 2. I have, again, two sets of parallel lines, and I'm going to trace my triangles. I've got a little blue triangle, and then I have a great big orange triangle. Okay, and since they're embedded, I've got to keep straight what goes with what. Now, I have the two lines parallel, which means that the corresponding angles are also going to be congruent. So I know that angle QPL is congruent to angle MNL. So that's one set of angles congruent. Well, again, since these lines are parallel, I know that their corresponding angles will be congruent. So now I have another set of angles in my little and big triangles being congruent. Now, I also happen to know that this angle, angle L, is congruent to itself. And so I could use that as well, but I don't need it. I actually have 3 angles worth here of congruence, but I only need 2 of them. And so I can say that yes, these are similar triangles based on angle-angle similarity, because any 2 of these sets would have worked. And so let's go ahead and write our similarity statement now. My blue triangle, I think I'll name the blue triangle, let's go with QPL. And so I'm going to say it's similar to this orange triangle. So the angle that matches up with Q is M. So since Q went first, M has to go first. Then I went across to P, which is this blue angle. So I'm going to have to use N for my next one. And then I had L at the end, and L happens to be the last one in my orange triangle. So they are similar by angle-angle similarity, and these are my statements. Looking at number 3 now, I have a right angle in this triangle and a right angle in this triangle. I know that all right angles are congruent. So that's one set of angles being congruent. Then, I have a 51-degree angle in the right-hand triangle and only 39 in the left. I could give up here, but I never do that. Instead, I think, well, I know this whole triangle needs to have all its angles summed to 180. So if I do the 180 and take away the 90 and take away the 39, I can find out what's left behind for here. And when I do it, it comes out to be 51 degrees. And oh look, since I have a 51-degree angle here, it will be congruent to the 51-degree angle on my right-hand triangle. So that's a second set of angles congruent. So boom, I have angle-angle similarity without even having to do anything else. But since I know me, I'm going to go ahead and realize, if this one had 90, 51, and 39, this triangle will also have 90, 51, and 39. So just keeping that in mind that yes, I know that all the angles match up. So now I can say that these, yes, are similar. And so this triangle on the left, I'm going to color him blue, is going to be triangle SYE. And I'm going to say it's similar to the other triangle. So I'm going to need to make sure to label my corners in the appropriate order. So S is my 51-degree angle, so I need to put the 51-degree angle first here. That'll be W. Then I went to angle Y. That was the right angle, so my right angle here is C. Then I ended on angle E. That's my 39-degree, so I'm going to end with the 39-degree angle here, which is H. Problem 4, I've got 68 and 54. When I take that from 180, this top angle comes out to be 58. And now I'm going to look over here. I've got another 68, so I do have a set of angles that matches. So I'm one down. Let's see if I can find another. And I've got 58 and 54 here. When I subtract these from 180, this comes out to be 49 degrees. So although I have one set of angles congruent, the other ones are not congruent. So no, these are not similar because I do not have 2 sets of angles congruent to make them be similar. Down here at number 5, I have that this angle is 67, and that is the point angle of this orange triangle. It's also the point angle of this big green guy. So all right, that's cool. Let's come down here. If this is 67 and 91, then this little angle right here is 22. Cool. So I need a 91 and 22 here. But when I have 67 and 25, this angle comes out to be 88 degrees. So although I have one set of angles congruent in my orange and green triangles, the other angles do not match up. And so first of all, I know that these two lines aren't parallel because their corresponding angles aren't congruent. But I also know that the triangles are not similar because I do not have two sets of angles that are congruent. On this last guy, I have one set of angles marked as being congruent here on the ends. And then my vertical angles in the middle are congruent. So yes, these are similar. And so I'm going to go with this left triangle is pink, and I'm going to try calling it PXQ. And it's going to be similar to this blue guy on the right. And since I started with P, that's this green marked one, I'm going to start with Z over here. So Z will go first. Then I went over to X in the middle, so I'm going to go over to X in the middle here. Then I ended on Q, and so I'll end on Y. So those are my similarity statements there. Another way to prove triangles are similar is called side-side-side similarity. Now, this does involve three sets of sides, just like when we did side-side-side congruence. But here, instead of three sets of sides being congruent, I need all the corresponding sides to be proportional. That means that each set of sides needs to be the same ratio when you work it out. And so I come over here and I'm going to look for which pieces go with which pieces. And so here I'm going to go, okay, it looks like I'm going to put this 9 with this 14. And so if I put 9 with 14, left to right, that's on this obtuse angle. And so now I'm going to take this other side of the obtuse angle and put it with this side of the obtuse angle. So that's going to be 13.5, still starting on the small side, compared to 21. And if I put that into my calculator, and yes, I am using my phone because why not? So if I have 9 divided by 14, this ratio is 0.64. When I do the 13.5 to 21, that's also 0.64. Then if I take this last set of sides and put the 20.25 together with 31.5, let's check that. So 20.25 over 31.5, that also comes out to be 0.64. So since I have three sets of sides all being proportional, I can say yes, these are similar triangles. And so let's write the congruency statement. I'm going to go with this first triangle on the left being KNR. So if I do K first, it's between the blue and pink. And so D will be the one that goes first here because it's between the blue and pink. Then when I went to N, it's between blue and orange. So the one between blue and orange here is E. And then my last one is R, so my last one here will be S. Making sure that I keep all the corresponding sides named in the right order. Come to number 8. This one is actually a bit simpler because since the triangles are nested, I know which side goes with which side. I know that this green side here is going to be, for the smaller triangle, I'm going to match it up with this long side on the big triangle. And so the big one, or the small one is 20. The big one is the 20 and the 8, so it's 28 altogether. So when I make the ratio, I'm going to say the small triangle is going to get compared to the big side. So 20 will go with 28. I don't do 20 with a part of a side. I do the small side compared to the big side. Over here on the right, I have the side of the small triangle is 15. The side of the big triangle is 15 plus 6, which is 21. And then the last set of sides, I've got the 30 being compared to the 42. And when I put all of these in and compare those ratios, if I simplify these down, these both divide by, let's see, this, whoops, sorry. So this divides by 3, so it will be, this one right here is dividing both by 3 is 5/7. These both divide by 4, which comes down to 5/7. And this one simplifies, both of these divide by 6, which will be 5/7. So all of these simplify to the same fraction, which means these are all congruent to each other. And so then, yes, by side, side, side similarity, I have all the sides proportional, so I can say that, yes, these are two similar triangles. And so I'm going to call the smaller one UWY. So if I do, or sorry, the big one is UWY. So UWY is going to be congruent to triangle VWX. And I just followed in the same order that I did the bigger one. Flipping over now. Let's try another one. So on this one, let's see. I need to figure out which sides seem to go with each other. Well, it looks like these angles almost look the same. And so I'm going to start with the one opposite. I've got a 16 and a 10. So I'm going to say that the 16 goes with the 10. Then over here, I'm going to put the smaller of the two leftover sides and the smaller of the two leftover sides together. So I'm going to put the 4 with the 5. Okay. Well, when I simplify this, this comes down to 8/5, and this simplifies down to 4/5. So these are not equal to each other at all. And if I were to even try the third set of sides, if I were to do the 7 to the 12, again, that is simplified and it is not equal to either of those ratios. Oh, I didn't even realize it wasn't showing on the screen. Sorry about that, you guys. So since none of these ratios are equal, I do not have side, side, side similarity. So these are not similar triangles. Coming over to number 10, I do know that these are congruent angles. And so these two sides coming off of each other are going to be ones that are compared to each other. And then the ones opposite the angle, the ones going straight across from it, these will be my two I compare. These are corresponding sides. So I'm going to put, let's see, 12, I'm going to put it with the 43.2. And waking up my phone so I can get to my calculator. There it is. And so when I figure out that ratio, 12 to 43.2, that's going to be 0.28. So I'm looking for ratios of about 0.28. Okay? And so if I do, on these guys, I'm going to take the 15 is bigger than 5 and 54 is bigger than 58. So the two bigger ones will go together. So if I do 15 to 54, I'm going to check that ratio. 15 to 54 also comes out to be about 0.28. And then if I compare the 5 to the 18, the ratio 5 to 18 is also 0.28. So these three ratios are all equal to each other. Since they're all equal to each other, I have three sets of sides that are proportional. So I have side, side, side similarity. So yes, these are similar. And so here I'm going to see, let's what, PAR is my first triangle. So it will be similar to triangle, let's see, P corresponded to Y, A corresponded to T, and R corresponds to itself. Number 11, looking to set up my sides. Aha, I have right angles. That makes it easier to find which parts are corresponding. Coming off my right angle, I have a small side and a big side. And so using my Pythagorean theorem, I can figure out that 5 squared plus b squared equals 13 squared. So 25 plus b squared equals 169. So b squared is 144, and b is 12. So I know that this side is 12. And then over here, when I do the same thing with my Pythagorean theorem, this comes out to be 23.4. And now I'm ready to set up my proportion and see if everything comes out to be equal or not equal. So along my right angle, I've got a short side and a long side, and a short side and a long side. I'm going to put my two short sides together. So I'm going to put the 5 with the 9. And then I'm going to put, coming around the other side of my right angle, I'm going to put the 12 with the 21.6. And then on the last side of my right triangles, on my hypotenuses, I'm going to have the 13 to the 21.6. And so let's see if these ratios are all the same. So 5/9, if I could type, 5/9 is 0.556. Well, 12 divided by 21.6 is also 0.556. So I'm partway there, but all three of them have to be proportional. So if I do 13 divided by 21.6, oh, sorry, that shouldn't have been 21.6. That should have been 23.4. Mrs. Cerna, get it together. It says 23.4 here, and I wrote the wrong thing. But here, 13 goes with 23.4. Oh my goodness, Mrs. Cerna. 13 goes with 23.4, and there it is, 0.556. So now all three of these ratios are equal. So my sides, all three sides are proportional. So yes, these are similar triangles. And I can say that triangle XYZ, if I go from X to Y to Z, I'm going down the long side and around the right angle. So X will go with V, so triangle V, and then W is my right angle, and then R will be left behind. Now checking this last guy here. Nested ones are usually the easiest to tell which sides are corresponding. So I'm going to have this orange triangle and the big blue triangle. And so the left side of the orange will go with the left side of the blue. The right side of the orange will go with the right side of the blue. So I'm going to have 6 going with my 16, which means here I'm going to have the 8 going with however long this whole side of my blue triangle will be. Well, it's 8 plus 12, which is 20. Well, and then my last set of sides, I'm going to have 9 going with 24. Well, when I simplify this, dividing both by 2, I get 3/8. When I simplify 8/20, these both divide by 4, and that comes out to be 2/10. Oh, my goodness, I did that wrong. 2/5. And then 9/24, these both divide by 3, and that's going to be 3 out of 8. So I have 2 of them that match, but 1 of them that does not. So this is not similar because all 3 have to be proportional in order to work. The last similarity setup we have is side angle side similarity. And the way side angle side similarity works is I need 2 sets of corresponding sides that are proportional. So corresponding sides are proportional. And the included angle has to be congruent. So the included angle is congruent. And so I'm basically mixing the other 2 sets. I need some stuff that's got proportional sides, and then I need the angle that's in between those proportional sides to be congruent. So looking at these 2 triangles, I have an angle that's congruent. And then, oh look, on either side of that congruent angle, I have sets of sides. So if I can just get these two sides on either side of the angle proportional, then I know that these are similar triangles. So I'm going to set it up. When you crisscross like this, you have to figure out which one goes with which. And it looks like here that these are flipped around from each other because this is almost right and this is almost right. So I'm going to say that the 6 will go with the 24, which will put the 48, which will put the 12 going with the 48. Let's see if that ratio works. So 6/24 simplifies to a quarter, and 12/48 simplifies to a quarter. So yes, these are proportional. So now I have two sets of sides that are proportional and the angle between them. So yes, these are similar triangles by side angle side similarity. And so I can say that triangle, let's see, SER, this one, will be congruent to triangle. Let's see, S is going to correspond to G, and then E will correspond with itself, and then F will correspond with R. For number 14, I have, let's see, I have this side, which will be contained with this side. Those two sides will be corresponding. And these two sides will be corresponding. And then I know that these two angles are congruent because they are vertical. But already I can say that I don't know if these are similar or not because this angle is not included in between the two sides I know. It's not the included angle. And so even if these were proportional sets of sides, which I'm not going to bother finding out, it doesn't matter because I don't have the angle between them. If I wanted to prove side angle side similarity, I would need this angle and this angle to be congruent. And I just don't know that yet. I don't have any parallels to help me out or anything else. So I'm stuck saying, no, I don't have enough information. Down for number 15, I do have some parallel sides. And so since sides are parallel, I can say that this angle and this angle are congruent to each other because they are corresponding. Here's the transversal that cuts my two parallels. And then I have a side corresponding to a side. And so I have 54 matched up with 33. And then over here, I have 36 matched up with 22. And if I simplify these, let's see, these divide by 3. And so this will be 11 on bottom and 18 on top. And both of these divide by 2, which would be 11 on bottom and 18 on top. So both of these simplified to 18 elevenths. So yes, the ratios are equal, so the sides are proportional. And it is arranged as side, angle, side. So I do know that yes, by side, angle, side similarity, these are similar triangles. And so I'm going to go with triangle, let's go with CMP, will be similar to triangle C matches up with R, M matches up with P, and P matches up with Q. For number 16, I do have a set of angles congruent, and it does appear that I have corresponding sides on either side of the angles congruent. I just need to decide which ones. So on this left one, I have a big and a small. And on this right one, I have a big and a small. So my big one on the right, I'll match up with my big one on the left. So 50 will go with 35. And I'll put my 45 with the 31.5. And so since I have side, angle, side, I just need to make sure that this is actually proportional. And so if I go into my handy dandy calculator here, 50 over 35 is 1.4. And on the right, 45 to 31.5 is also 1.4. So yes, I have proportional sides with an included angle. So yes, these are similar by side angle side congruency. So I can say that triangle EGF will be similar to triangle. Let's see if I do E to G, that's going down the orange, so J to H. And then I had F here, so it'll be K there. Again, making sure that I match up corresponding angles to corresponding angles. On number 17, I have a small triangle, which is this pink one, and I have a big triangle, which is this blue guy. Now, both of these triangles contain the angle here at the point, and then they have the sides on either side of that angle. So I can hope for side angle side here, but I need to make sure that I have my proportions. So the small triangle has 15 here. The big triangle here on the left, its whole side is 45. So I have 15 going with 45. And then on the right, my small triangle has 14. And my big triangle has 42 here. And so when I compare these ratios, these both divide by 15, it becomes 1 to 3. And these both divide by 14, which is also 1 to 3. And so yes, these are proportional, and the included angle is congruent to itself. So yes, these are similar. And so I'm going to say my little triangle, let's go with QWR. I'm going to say it's similar to my blue one. Q will match up with S, W will match up with itself, and then R will match up with Z. And lastly, last example we're going through. I again have two nested triangles. They have this side, this big blue side, going with this little orange side. And so this is going to be 34. And then I have this big blue side, which is 39, going with this little orange side, which is 30. And then they share an included angle. So I have an angle in both triangles being congruent. And I have either side that I can compare, but I need to make sure that this ratio is equal to this ratio. So on the left, I have 30 to 39. And on the right, I have 27 to 34. Well, when I put that in here, I can't really, the fractions aren't going to be the same, but when I simplify it down, 30 out of 39, that's approximately 0.77. But when I do 27 34ths, that's 0.79. So these sides are not proportional. So these are not similar. And that's what you're going to be doing. Remember, your three ways to prove triangles are congruent, are similar, are side angle side similarity, side 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 similarity, and angle angle similarity. Thanks a lot, and y'all have a great day.